Good afternoon and welcome. Thank you for joining us for our webinar on meeting the high basic standards that will commence later this year. Today we have with us our industry stakeholders who will share their experience on designing homes to meet the high standards and help you build more sustainable homes. My name is Tim Archer and I'm the Director of Stakeholder Engagement and Economic Recovery here at the Department. I'll be facilitating today's session and I'm joined in the studio by Daniela Carrick, Acting Executive Director, State Policy and Strategic Advice, Ian Fry, one of the state's very experienced basics assessors, and Martin Perez, Senior Draftsperson with Edgewater Homes. Troy Daly and Hayley Edwards, experienced sustainable building consultants from Efficient Living, will be joining us remotely. Just in terms of today's agenda, we have a number of presentations. So Daniela will give a policy overview, which will provide the context for today. Ian will give an overview of the design considerations for meeting the higher standards for houses. Troy and Hayley will be sharing their work optimising apartment designs to meet the higher basic standards. And Martin will discuss his work on designing prototype house builds to create more sustainable homes. And then we'll have a Q&A. We have some questions that have been sent to us as part of the registration process, which we'll go through, and then we'll go through some live questions as well. Just some quick housekeeping. So if you have any questions, please enter them via the Slido window. Well, as I said, we've also received a lot of great questions during the registration process for this event, which we'll go through. Obviously, this session is more focused on how to apply the higher standards than the policy itself. And we're keen for questions that take advantage of industry experience that we have on the panel today. Live captions are also available. You can switch them on as needed via the CC icon on the media player window. And this session is being recorded and will be published on our website the next day or so. If you have any technical questions, in the first instance, there's a question mark or a help engagement tool located at the bottom of your screen. And with that, I'll hand it over to Daniela.
Thanks very much, Tim. We are all always on country. Today I acknowledge country and the deep connection of Aboriginal and First Nations people to the many countries where we live, work and play. We are coming to you from Darug country, located at the mouth of the Parramatta River, known as the place where the eels lie down. I pay my respects to the Barramadigal people and to all elders past, present and emerging. I thank them for the deep care they have provided country for millennia and continue today. As Tim mentioned, I'll be providing a quick overview of the updated basic standards. As you know, the Sustainable Building SEP was notified on the 29th of August last year. The Sustainable Building SEP and its accompanying regulations, which amend the Environmental Planning and Assessment Regulation, will come into effect on 1st of October. The SEP itself includes updated sustainability standards for residential development, and it also introduces sustainability standards for some non-residential development also. When the SEP was notified last year in August, we offered some guidance and additional information to allow industry to adjust to the higher standards. So we've given 14 months until 1st of October for industry to adjust. And in addition to that, we've introduced a number of other initiatives, including the rollout of our early adopter program. And I'm very pleased to say that we have one of the early adopters with us in the studio today. We also released a sandbox tool so that applicants can input their designs and modify them and work out how best to meet the new standards. We've also hosted several webinars which are available for download, and we've got frequently asked questions online. In the coming months, we are also going to provide additional case studies online and some sample specifications specific to different climate zones across New South Wales. We're also releasing the DIY thermal tool in August this year. In addition, we're also introducing a planning circular which will clarify some aspects of the policy, so the SEP itself, and technical notes, and we'll also be releasing a plain English guide. So, what is changing with the higher standards? Up until now, we've had 3 indices we measured through basics. We measure water efficiency, thermal performance, and energy efficiency. For the first time, from 1st of October, we will start to measure embodied carbon in construction materials. The water standard is not changing this time. However, the thermal performance standard is increasing to 7 stars, and the energy efficiency standard is increasing between 7 to 11% increase in greenhouse gas reduction. The higher standards were underpinned by a very comprehensive cost-benefit analysis. We also undertook sensitivity testing before the SEP was finalised in August last year to account for rising interest rates and also increasing energy prices. We acknowledge that in order to meet the higher standards, it may cost a little bit more to build to these standards. However, home buyers will be better off, in our view, because that additional cost will be spread across the lifetime of the mortgage, while they'll benefit from reduced energy bills. So, for instance, a household in Blacktown will be better off by around $680 a year by living in a home that's built to the higher standards. Similarly, in Dubbo, households will have an additional almost $1,000 every year if they live in a home that meets the higher standards. Where the cost-benefit analysis was not favourable, which includes in the North Coast climate zones and for low-rise residential apartment buildings of 5 stories or lower, we are not proposing higher standards at this time. One of the things, before I hand over to Tim to introduce our next speaker, that I just wanted to flag, and it's certainly come through some of the questions that have been logged, and that's around the transitional arrangements. From 1st of October, if you prepare a basic certificate using the online basics tool from 1st of October, you will be required to meet the new standards. However, one thing worth noting is that a basic certificate is valid for 3 months. So what that means is that if, for instance, you generate a basic certificate end of September, that certificate will be valid up until sometime in December, so for the full 3 months. The fact that the SEP is commencing on the 1st of October will not invalidate that certificate. I might hand over to you now, Tim, to introduce our next speaker. Thank you.
Thanks, Daniela. I now welcome Ian Fry, the Director and Founder of Fry's EnergyWise. Ian is one of the state's most experienced basics assessors and is a member of the National Technical Committee for Design Matters. He has formal qualifications in building and construction, thermal home assessment and HIA Green Smart. Prior to establishing Fry's EnergyWise, Ian held various managerial roles with AV Jennings and other building companies. Ian will provide design considerations for meeting higher standards for housing.
Thanks, Tim. Well, thanks for that background. I guess there's probably not much use me going over my current background for the time being. Tim's pretty well covered that, but it's fair to say that I guess I've been in the industry for a fair few years now, and completing over 30,000 basic certificates. We're starting to get the hang of it now, so we have a pretty good idea what's required. So hopefully our presentation will give you a bit of a hand to understand a little bit more about 7 stars and what's required to get you there, and and hopefully give you a bit more comfort that it's not quite as difficult as what everyone seems to think. So if we have a look at what's changed, we're already starting to see some changes in the way we're building houses already. As you can see by the image that's up on the slide, we're starting to see smaller lot sizes. We're starting to see bigger homes. We're starting to see designs with more windows. All of these factors are not contributing that well to what we're trying to achieve here. So we need to start changing our thinking in some of these areas. We're seeing larger voids, or we're seeing more fixed glass. Both of these aspects are contributing heavily to the overheating of houses, and we need to find ways to fix that. The dark roofs are also contributing to that as well. And we're seeing a lot more home designs now where we've got well-designed display homes out there. And I remember my days back in A.V. Jennings when we had a display home, and if someone wanted to change it, it was almost taboo, whereas today it's almost becoming second nature, and it's almost being encouraged in most cases, and that's also not helping us trying to get the designs to suit solar access. So what are some of the changes we're starting to see? Well, most of the builders out there that would probably already start to see, a lot of their assessors are actually already starting to make some changes, and part of those reasons are for what I've already mentioned and what we're dealing with at the minute. We're already starting to see increased levels of insulation. We're starting already to start seeing in some of our assessments the use of low E and double glazing. We're starting to having to look at including things like ceiling fans to help try and cool the homes. And in a lot of cases, that also is contributing to help reduce the amount of glazing costs. External colours are being more and more important. We're trying to look at using colours more suited to the environment. And we're looking to do things like adding external blinds and that type of stuff to try and help protect a lot of the summer sun from entering the house, and that's also, I guess, helping a way of keeping the house cool and avoiding having to do large-scale improvements to windows. So I think there's a need to start to rethink the process. I think from when we look at the current situation of what we've got at the minute, I liken it to trying to fit a square peg in a round hole. Eventually you can massage it, you can try and get it there, you'll do lots of work on it, you'll eventually get it to fit. But it'll take a lot of work, it'll take a lot of time. And when you look at that back as a thermal assistance type of product, you're finding that's going to add a lot of cost. The idea of actually having to try and estimate the amount of costs the 7-star compliance is going to be and putting that as a PC sum, I see that as being really dangerous because depending on the design, depending on how well it's suited to the block of land, those costs can vary dramatically. So if you've got a bad design sitting on a block of land that's not favourable to solar orientation, you might find the cost of that could be quite extreme. Whereas if you've got a building that's well suited to that design, your costs don't go to anywhere near as much. So I don't recommend trying to sort of estimate the price up front. I think the basics of solar design will be key. I think it's very important, and it'll be at the forefront of any discussions that you have right up front, will be looking at the house design and making sure that that house design is suitable to the orientation. And it really is pretty simple. I mean, all we're trying to do is we're trying to maximise the amount of winter sun we can get into a house to keep it warm, and we want to try and block out that hot summer sun. Just by doing those two exercises alone, you'll find you'll make a much bigger difference to the performance of the home. We're recommending that we need to bring the thermal assessment, your NATAS assessment, much forward in the process. Getting those assessments done early in the process is going to make sure you get a much better understanding of costs. You'll understand what's involved. Your homeowner will be more comfortable understanding where the costs are. The costs aren't going to go away. They're going to be part of the house anyway. It'll be a good idea to find out what those costs are before you start. It'll also be a good indicator to find out how suitable that house is going to be to that block of land. So excuse the pun, but I don't really think 7 stars is going to cost the earth. Look, improved window systems are a given. We know we're going to have to go down that track, and that's fairly important, as well as increased levels of insulation. So we're going to have to look at increasing our external wall insulations and maximising that as much as we can. That's a fairly cheap cost, so that is also a given. we need to look at increasing our roof insulation as much as we possibly can. But I must add that we've got to be very wary of that. With increasing roof insulations, there are some certain aspects that you need to think about with that, and that's things like making sure that, depending on the level of roof insulation you're using, you need to make sure that you're not pushing that into corners and compressing it. Not only is that going to make lesser performance of that insulation, it's also contravening the Australian standards. So you need to be very careful as to how you deal with that. We need to think about the colours that we use in the houses and try and use colours better suited to the environment. And potentially, once the assessment's done and you understand what the heating and cooling load limits are for the house, we may need to be a little bit flexible in the colours that we select, because that again will help reduce the added costs. By putting light coloured roofs in houses that are failing cooling loads, we'll avoid the other additional costs which are offsetting that, such as improved windows and taking them to another level. And I've mentioned before, selecting the right home design for the block, absolutely critical. And that in itself will save heaps of costs. So, you know, if you're trying to fit a bad design on a block of land and then trying to massage it like we talked before, that's where you're going to find the costs are going to be exorbitant. And I say again, conduct a pre-energy assessment. Make sure you get the assessment done early in the process so you understand the cost and you understand the suitability of the design. So what are the key things to avoid? Well, I guess we've already probably covered off of them, and if you add them up, you've probably already identified where they are. But obviously we need to select the right home design, making sure we're taking full advantage of the passive solar orientation. Try and avoid estimating the variations so you can get a pre-assessment done first. Glass to floor ratio is a fairly critical factor. I guess the best way to give you an indication of that is that if you're looking at an insulated brick veneer wall with an R value of exceeding R3, and then you compare that to a piece of glass which is maybe 4 millimetres thick, probably got an R value of probably around about R.2. So quite a significant difference. So you can see by having extensive glazing in a room compared to an insulated wall, you can see where the benefits of trying to reduce that glass is going to come from. And if you can't reduce the glass, then we've got to do our best possible effort to try and improve that glass to the best efficiency that we can. Try and control the flow of heat in and out of the glass, and both from inside and outside, and try and control the amount of solar gain we want to come in through that glass. We're seeing lots of voids coming into designs now, and whilst a lot of people like them and they create quite a good opening in design, they're also a bit of an issue for heat sinks. So what we generally find is that the heat gets trapped in voids and is very, very hard to clear. So once you get heat into a house, it's very difficult to get it out. So obviously the main aim is to try and reduce the amount of heat you get in through a house. But then if you get situations like this, you've got to find ways of trying to overcome it. And the use of fixed glass, and then you have voids together, two of them counteract each other. So try and use a lot of louvered or opening windows in voids to try and get rid of that heat, and the use of ceiling fans will also help. The other issue that we've found with windows at the moment, with some of the assessments that we're doing, is that having windows with a very limited range, and to be fair to the window companies, there hasn't really been a dramatic need required in order to put out an extensive range of window systems. So in what we're doing at the minute, we're finding that when we're going to improve a window, when we've got a limited range of windows, we're finding we're having to go to a next level in a window system in order to try and meet compliance. And usually that means it's overspecified. So what we're trying to do, and there's a lot of window companies out there working very hard and starting to increase their ranges, which is good. So you need to speak to your, try and identify your window company, work with them to try and get a bigger range of windows so you've got more selection, which means you can get a better fit without having to go to extreme costs. And we've already talked about the benefits of committing to a pre-assessment before you start. So as a builder, what are some of the things that I can suggest for you to start working on for 7 stars? Well, the first thing we're doing with a lot of our builders at the minute, and I'd highly suggest you talk to your assessor about, is actually starting to assess some of your display homes for 7 stars. So you can get an idea of what's actually required for that particular home to meet 7 stars. You can also work with your assessor to model that house in various orientations, so you can actually see how that home design will work in different orientations and maybe the sorts of orientations that house might be better suited to. It'll also give you obviously a very good indication of costs, and so you can actually then start preparing your specifications for that home based on those assessments. Review designs with higher glazing. So look at ways that you can try and avoid it. If there's an opportunity to try and move some of the glazing or probably reduce some of the glazing, try and do that where you can. If not, then you need to look at things like shading options, and maybe then you need to also consider using high performance glass in those particular rooms where you want to try and retain your glass. Obviously, improving your standard level inclusions is going to be critical. Getting your high level of insulation as a standard, and obviously working with your window supplier to get the best possible window systems affordable for that design. The higher the specification, the less shock there's going to be at the end when you make that move. So in our belief, the fact that you've got a higher level of inclusions will actually be a great marketing point. Once you've done your assessments, review those assessments with your NATAS assessor. So you're making the best effort to try and get those assessments, get the specifications right for that particular design. And upgrade the knowledge of your salespeople. So salespeople start to understand the importance of passive solar design. They're comfortable dealing with it. They can select homes, talk to clients about it. It'll be a big plus moving forward. And from a home buyer's perspective, some of the things that a home buyer needs to think about is the same sort of things. Consider the site orientation when settling on a design. Look at the builder's inclusion levels to look for a builder that's got higher inclusion levels so that there'll be less cost at the end once it's sited. Being a bit more flexible on the colours that they choose and the floor coverings they choose so that they can minimise the amount of added costs. Ask your builder for a pre-assessment of the house and the land before you commit. Look at neighbouring properties on the property and have a look and see what sort of overshadowing is potential for that home design and how that may be negative or positive in the particular home design, and what sort of shading you may need to actually shade the hot summer sun for that particular design. If you've got a particular house design you're fixed on, and you can identify that there's going to be some lots of heat entering the house through a particular elevation, find ways to overcome that and talk to your builder about that sort of stuff. So look, there's some great sites that you can go to that you can get some more information. I don't know how many people have been to the Your Home website, a great website to get an understanding of sustainability and how you can build a sustainable home. There's also got some great tips on how you can build more energy efficient homes and some of the tips for that as well. The National House Energy Rating Scheme, NATAS, and the National Construction Code also have information relating to 7 stars for the more technical type of people that want some information. I know BASIX is shortly bringing out a document to guide you through 7 stars and to help you through the new BASIX setup. And even on our own website, we've got some fantastic tips for people using a video series where we've got an animated home buyer, Greg and Sue, who will take you through the steps of understanding some of the changes that are happening with 7 stars and helping the tips, not only for home builders, but also for the home buyers, but also for the builders as well. I think you'll find it really helpful. So thanks very much for your time. I think we've got a question and answer scenario at the end. So if there's something I haven't covered, something you want some information on about, I'm more than happy to answer it afterwards. Thank you.
Thank you, Ian, for crunching down, no doubt, years of experience into some well-defined set of principles. So I now welcome Troy Daly, Senior Consultant, and Hayley Edwards, Residential Consulting Manager with Efficient Living, who are one of the largest sustainable building consulting firms in New South Wales. They have a team of engineers, architects, building designers and environmental scientists who have optimised the thermal comfort and energy efficiency of thousands of residential projects, from architectural homes to landmark multi-use commercial precincts. Today they'll be talking about optimising apartment designs to meet the higher basic standards.
So thank you. I'm going to talk generally about the principles for apartments to transition to 7 stars and to the new energy standards as well. And then my colleague Hayley will talk more specifically using a couple of actual worked examples too. I would say too, it's important the context for the bigger apartment projects we work on as well. More often than not now, we'll be working in a design excellence environment with a design review panel. And as always, we're working with apartment design guidelines as well, which can work sometimes to create a bit of a balancing act around how an architect will design a building. It'll sometimes conflict, sometimes complement thermal performance too. So that's our backdrop. If we could move ahead to our slides, please. And the next one, thank you. So just touching base on where we're actually at today. The average apartments are scoring around 6.5 stars from a thermal point of view. That's a great starting spot. Now, that being said, it will more often than not be the problematic apartments in an apartment block that need the most work to get them up to the bottom end of the permitted standard, not so much the average, but 6.5 stars is a good point to actually start from. If you look at the histograms I've got on the right there, you'll see that since these standards have come in, the big movement to get to 6.5 stars has really been through improved window performance. So the values of those windows dropping down into the 3s, you can see that bar there. I'm sure we'll look back in 5 years' time and we'll continue to actually see that actually move down the U values to actually sit around 2.5 to 3 going forward as well. Now we're seeing a pretty fairly diverse approach to apartments, and they're very different building shell models people are using, from sort of stand-up panel designs through to cladding, through to brick veneer still at the moment. There's still very different attitudes to the amount of glazing ratio to floor space as well. People are seeking to solve that problem when it's created generally with very highly spec'd windows and they have a very high window to floor space ratio. We're still not seeing enough forethought to deal with ventilation and something as simple as ceiling fans as well. We're probably still not seeing enough forethought when it comes to a number of other issues like thermal mass as well, those sorts of things. It's great as we go forward now as well. We have been in the current environment starting to encounter big problems on all electric buildings. It's a fantastic change the guys are making at Basics to actually move the carbon intensity for grid sourced electricity so much lower, not just to today, but to actually broadcast forward for the rest of this decade and take that average. That will certainly put electric appliances and centralised systems on a much better playing field. All right, so if we move ahead there quickly to thinking about what are the key steps to actually get to. It's very hard to avoid talking about windows, but for the sake of fundamental measures to actually help achieve 7 stars from a thermal point of view, it's good to know that intuitively you would say that keeping the glazing to floor ratio down makes sense. And it's really nice to see CSIRO's actual evidence base here on the screen in front of you, basically confirming that keeping window to floor ratios below 30% is a pretty fundamental starting point to help you hit 7 stars. It won't work on every single occasion, but it's a great starting point to put you as far forward as you possibly can. There's big side benefits for keeping that window ratio down as well. So if you've kept your window ratios down, particularly in east and west orientations, you're also pulling back the potential cost of shading structures and other things that you'll need to work on later in a refinement stage to do things too. So if we can just move ahead another slide, please. So you'd see from both a design and from like a building shell point of view, focusing on those window ratios would be our starting point. It will be a challenge. There'll be a lot of architects out there that are receiving guidance that floor to ceiling is a big selling point and impacts the revenue side of projects. And no doubt to some extent that's correct. I would comment though, we do actually see a lot of premium apartment developers as well working off these much lower window ratios and still coming up with a product that's very acceptable and attractive to the market as well. So that would probably be our first point. Moving on from there, we drop then. Sorry, no, if you just go back one slide, that's right. Moving on from there, there's still when you've got that correct, and you have actually then scoped your best shading structures. You have tried to get the walls to R2.5 and R2, being wary of working with other consultants, and if that does require sort of fire retardant type insulation, then that's what's been specified. We will still inevitably at a point where those window systems with very low U values, and probably moving into thermally broken glass will be, thermally broken frames will be required through time to actually hit the measures. So windows. First, moving on to building envelope, moving on to optimizing those shading structures over windows as well. Plus a realm of technical things after that too. Just talking about energy really quickly, it's been for everyone becoming somewhat more frustrating over time to actually want to specify all electric appliances, and this comes up with us a lot in design review panels, and having basics in some ways penalise that outcome. Going forward, basics energy will be quite exciting, I think, because it brings electric services basically to a level playing field, because the guys have actually corrected the carbon intensity on the grid versus carbon intensity of gas appliances. So now that that's at a level playing field, it's much simpler to actually get the basics right for an all-electric building, which is really encouraging. And we'd encourage everyone in the basics energy now to be doing the actual modelling around that agenda to actually demonstrate that gas should become a sort of a second-rate option from now on. I'll just finish off before I pass on to Hayley straight away too, and re-emphasise what the prior speaker said, which is that bringing the NATAS assessment earlier will be more beneficial. We need to work in more detail with acoustics, more detail with fire, probably more detail as always with the architect too. So bringing that modelling assessment for thermal earlier on and for energy earlier on for interaction with the services engineer will get the client a better outcome in the long run too. I'll sign off there and over to Hayley for some specific examples.
Hi. So I just want to reiterate what Troy said about the energy section of basics. So in the industry, there's a lot of talk about increased energy targets, where we've found in class 2 that a lot of the work has to be done in meeting the NATAS increase to 7 stars, as opposed to in the energy section of the tool. Our sandbox testing at the moment is showing class 2 buildings to be really quite favourable in the new tool. And it's quite exciting, like Troy said, for our clients to see their projects in comparison and how well they're doing in that new tool. Although the target has increased quite a lot, it's not very onerous to meet the new standards. The biggest work is involved in the 7-star NATAS compliance with apartments. So on the screen here, we're looking at a project which we've put through some of the testing tools. There's been various ones available, not all perfect, but a great indication of how we're tracking. So next slide, please, if you could, thanks. All right, so this project is already performing at a really high standard. So they're at a current 6.6 star average, which is really good performance in the industry right now. And it's actually typically where we would see most apartment complexes performing. So the first apartment example there is showing quite a favourable orientation and a well-designed apartment, which just has to have a minor increase to that glazing spec in order to reach the new 7-star compliance. The next example there that we're looking at is a less favourable design, an end apartment, which is quite exposed. And it's important to note, I guess, that in an apartment complex, 80% of those units might perform quite well. And it's that 20% that you've really got to focus a lot of time and energy on to get them to the new standards. So we've got quite a significant glazing upgrade there. But the biggest impact on this particular design was the fact that we did have to make changes to the design itself. So we've included ceiling fans. They're very, very beneficial in meeting these new cooling loads. Including them in the bedrooms and living areas is very important. We have reduced the glass to floor area ratio, so taking those facade windows to a 1500 high as opposed to full height glazing to the entire facade, and introducing some shading screens to the northwest orientation as well in order to reach the new targets. Next slide. Okay, so here we're looking at a less favourable apartment complex. So it is just scraping by with minimum compliance at the moment. And it's quite a large footprint. It doesn't have a huge glass to floor area ratio, but it doesn't have a great orientation. Next slide. So in order to get this apartment to pass, we've had to do quite a lot of modifications and reworking of the specification. So its current spec, minimum compliance, just scraping by, the performance of the unit itself was a 4.6 sorry, and increasing to 7. The most challenging aspect for this particular one was reaching those new total loads. We're finding it quite easy to get that heating and cooling load, but once you've got to get that total load, you're really investing the time and energy, and that's where you find you have to make a bit of a glass specification change to get that. So we've got a glazing upgrade going on there. This is a rooftop apartment, so we've had an increase to the ceiling insulation, which can be a little problematic in apartments when we're dealing with building heights. So something that you'd have to really talk to your clients about. We have increased thermal mass. So the bottom of this building is brick veneer with the top floor being lightweight. So we have continued that brick veneer for the entire development and increased that external wall insulation. We have introduced some secure fly screens there to just get a bit more ventilation into the apartment itself. And we have also had to reduce some of the eave lines to the south that were really impacting the performance of the unit. So overall, in our testing, we found that the majority of clients are actually performing really quite well, with most jobs at that 6.5 star mark already. And it's just getting those 20% of apartments that are a little bit more problematic, not the best orientation, maybe sitting above a basement car park or big penthouses where the work really has to go into them. Glass to floor area ratios, very critical, and getting your NatHERS and SESAR involved early on in the process to review designs, provide some advice is definitely important in ensuring that the whole tower is going to meet both individual and average building performance. Thanks.
Thank you, Troy and Hayley. Another great presentation, a lot of insights. I now welcome Martin Perez, Senior Architectural Draft Person, Edgewater Homes, Henley. Martin has a wealth of knowledge and experience and achievements from over the last 15 years in the construction industry. He's passionate about building a greener future. Today he will discuss his work leading a team to redesign prototype house builds as part of Edgewater's commitment to building more sustainable homes.
Thank you, Tim, for that introduction. Excuse me. So in March 2022, we were invited to take part of this initiative by the New South Wales Department of Planning, the Department and Environment, known as the BASIC's Early Adopters Program. So today I'll be presenting those findings from the initiative and give you a bit of insight and considerations into the takeaways that this initiative has done for us as a home builder. So our team consists of myself, Aidan McGackie, and Amy Callahan, one of the Henley members, draftspeople in our Henley division. She has had some workings with Sustainability Victoria, and that's why we thought we'd bring her into our team, just so that we can get a broader perspective in regards to not just New South Wales, but what's happening in our Victorian counterparts as well. So also we work closely with our energy consultant, Connor Horwood from Enviro. Together we bring these results to you. Just a quick overview of who Edgewater Homes is. So Edgewater Homes is the New South Wales division of the Henley Properties Group. We specialise in residential housing, from standalone ready-built products to medium density townhomes. We work in conjunction with some of the New South Wales leading land developers, the likes of Lendlease, Stocklands and Harrington Estates. We also have our own master plan community out at Ascot Grove in southwest Sydney. It's about 200 homes big. So the Early Adopters Program. This was an initiative brought in by the department. It was to work with builders who are ready to take on the challenge of a higher sustainability standards, meeting a 7-star rating and a higher BASIX requirement. Builders were tasked to monitor, assess, and the outcomes of the higher sustainability requirements on a 2-property prototype build. I'm now going to present to you this case study that we were involved with. So I'll give you a little bit of context before we get into the results. So our team first undertaking was to find out a basis point. With a bit of knowledge of the ESB methods, we opted to choose 2 opposing lots, making the orientation the key factor to consider. We then categorized each of these lots as a best case and a worst case scenario. So the location we chose was one of our own, within our own estate at Ascot Grove. This is in a predominantly suburban landscaped area. So the rationale behind this is that we were able to have improved ability to navigate building limitations, address time constraints against approvals, for example, or registration of land, and effectively monitor the future energy output of these dwellings. Each lot, as you can see, is also roughly 350 square metres. The dwelling types, both are Class 1A buildings, single-storey brick veneer structures with a treated pine internal frame and a waffle pod slab construction. As you can see also that there are both 4-bed, 2-bath, 2-garage. So your typical residential home that you'd see in all your estates these days. So also you can see in the diagram that the lots have opposing street frontages. Again, this is to reiterate that this is going to give us a better understanding of how solar orientation is going to affect our design and energy expenditure. So I've listed here the specifications for both the builds. They're exactly the same. We've also then divided these into the 3 key areas within the BASIX tool, that being water, energy, and thermal. I want you to please take note as to the products and the standard of the level of insulation under the energy and the thermal sections, as these are the factors that will be greatly affected when you see the results. Also take into consideration the window. So our standard was a single glazed aluminium frame window. So by specifying these specifications, we aim to closely align with what other builders are using. Okay, so we just wanted to start with a starting point that across the industry was standard. This will enable builders to establish stronger connections between their designs and this modelling. So on to the results. So here are the results for the case study number 1. we identified this as the best case scenario. The reason for this, it had a southwest northeast orientation with the living areas facing the northerly aspect. As you can see, there's the alfresco area. That's where the largest habitable room area would be. To meet the 7-star thermal requirements, we noticed the NATHERS report coming back with an insulation rating needing to be increased. As you can see, the insulations are now R2.0 for walls and R4 for the ceilings, compared to the 1.5 for the walls and the 3.5 that was the standard spec. We also then had to introduce sarking, as that wasn't standard within our standard spec, and at a minimum, a low E glazed window had to be provided, so across our house, apart from the wet areas. For energy to pass, we opted to choose a solar gas boosted hot water system. There's a number of factors in this. We had to factor in what our company could source, but also what the market was also asking. So some of the market out there was still asking for gas, and so therefore we still had to cater for that. Just keep in mind in these case studies. So conversely, we have case study number 2. This dwelling had the northeast-southwest orientation, with most of the living areas situated within the southerly side, an orientation that is not ideal, and that's why we've labelled it as the worst case. Although this dwelling did pass BASIX and met the 7-star NATHERS rating, it didn't fare well in regards to the specifications. To meet those ratings for the NATHERS, insulation was a lot higher than our standard and a little bit higher than what our first case was. Again, we still had to introduce sarking to the roof. And what stood out to us the most was now our windows had to be double glazed with argon filled and a low E to meet the minimum requirements for the U values there. Energy, again, we opted to go with the solar gas boosted hot water system compared to an electric heat pump or full solar PV system. So comparing these two lots and the results we got, we came to the following outcomes. Block orientation and design of your dwelling. In particular, the position of the large habitable rooms in relation to the northerly aspect will play a major factor in dwelling energy and thermal properties. With regard to the thermal properties, we see that minimum standards of our spec will need to be adjusted and meet these increases, paying particular attention to insulation and window glazing types. You also need to take into consideration in the energy side of the BASIX, what power source you'll be using, how you will be heating your water, and how you'll be heating and cooling your house. So building specification standards will need to change to meet these higher standards and to be the new benchmark to create more efficient houses. So during our testing phase, we did notice a few challenges. So at the pre-construction level, determining block size, orientation, this was purely dependent on what was the available product in the market from land developers, infill lots, the like. We noticed that small, skinnier blocks, not rating very well within these new higher standards. Secondly, finding and sourcing products that would meet the minimum ratings set by the NATHERS and the BASIX reports. In particular, meeting the energy requirements, such as, for example, the STC rating for heat pumps. Our findings showed that most of the products we reviewed in the market lacked providing the specific STC information, nor could they provide a high enough STC to the product to meet the minimum requirement. So I'll probably want to urge a lot of the products out there to start looking at their ranges and starting to meet those higher requirements. Specifically, with this testing, we did look at heat pumps, and most of the heat pumps out there, we were finding that an STC rating of maximum of 26, when the minimum requirement we were seeing was at 30. So just something to be aware of. And finally, let's consider cost. Everyone's probably thinking about cost. It is evident that there will be an increase in the cost. As you can see in these results, we experience higher expenses due to enhanced insulation, window type, product selection, and other miscellaneous factors beyond the initial standard specification. Based on our estimations from these two builds, the costs escalated by approximately $10,000 to $15,000. This was estimated in August 2022. So after completing the testing phase and collecting results, we were faced with the decision of either retrofitting existing designs or creating new designs. Oops, so go back. So what lessons has the business learned from this experience? So the importance of proactivity, collaboration, and effective communication. Edgewater Homes, together with Henley, have formed core technical teams to begin developing new designs to meet these higher standards. We are in constant communication with our internal teams, energy consultants, supplier base, to share and gather information so that we can all be on the front foot together. By also sharing these results to land developers, they are assigned to develop their own sustainable specifications and creating efficient master plan communities. I know that working with Lendlease, they're looking at an all-electric community as well, so watch that space. As for our customers, Edgewater and Henley have started, are in the motion of promotional advertising via social media and also through their sales team. We are getting the word out about the upcoming higher energy requirements. So as to conclude, let me leave you with these final words. This transformation will not only have a positive impact to environment, but also result in the creation of improved, efficient, and harmonious living spaces for our families that we all aim to support. So thank you very much.
Thanks, Martin. Appreciate you sharing your experience and your research, and it's great to see those technical details come alive through those case studies. Now we'll do a Q&A. We've seen a lot of questions come through, which is great, and there's also the pre-registered the questions that came through with the registration. So I think maybe we'll start, and I know Martin covered this in his presentation, but I think it's probably worth speaking to again. How much will it add to the cost of an average home?
Yeah, so as my presentation there, for that first case study, we looked at approximately $10,000. So, you know, that was the insulation, the window types, the like. So, you know there's an increase there. And the industry's just got to have to start to prepare for that. We did also see there was a material increase already anyway. So, we're starting to factor that into our costs as well. So, also in that higher, so the worst case scenario there, the case study number 2, we saw a $15,000 increase. That was because of the higher window type. There was more in regards to those windows were a custom window to us. As being a spec builder, we like to rely on, having reliable payment sources, that kind of thing. So, we like to keep our costings in line, and that just fell outside of that. So.
Great. Thanks, Mark. Ian, did you? Oh, sorry, Daniela.
Oh, no. Did you want to?
Look, I think it's very hard to put an actual figure on it because I think it really does come down to the design. Comes down to the amount of glazing in the design, comes down to the orientation. So I still go back to what I said in my slide presentation. I think that if you select the right home design for the right site, then I don't see it being an extensive cost. It's where you're trying to manipulate having a bad design on a site and you're trying to manipulate that design to try and make it work. That's where you're going to find the costs are going to come in. So, I think that if you do your research, you look at your site first, look where you're building, and get that right, then I think you can minimise the cost quite a bit.
Daniela?
All I just wanted to add to that was that when we did the initial cost-benefit analysis and the sensitivity testing, we acknowledged that it was going to cost more, and that cost varied depending on the size of the dwelling, where it was across New South Wales. But even when you look at that additional upfront cost, which is spread across the lifetime of a 20, 25-year mortgage, you were still going to be better off. So the occupier was always going to be better off because their energy bills were going to be substantially less. So we had to take that into account. And I guess that's important because I think when Edgewater Homes and others are going out there and talking to their customers, to their clients, it's a really important message. You're going to have a more comfortable home. So yes, you're paying this much upfront more, which is going to be spread across, might be an additional, $50, $100 a year to pay off your mortgage, but you're going to have $600 at the end of the year in your pocket because you've saved that in energy bills.
Thanks, Daniela. I have a few questions here on glass, but before I just wanted to acknowledge the team sitting behind the scenes answering a few questions as well. So there might be a few that they can answer in the background, but let us know if you need a bit more information on those. So maybe one on glass, given there's quite a few thumbs up. So maybe over to you, Troy, with will the new basics update the clear Lowy glass ratings? The Lowy glass requirements in basics can't be achieved with clear grey tone glass, which only meet the requirements. Is that one for you, Troy?
That one's too technical for me. Hales, would you have any view on that one?
Yes, I'd probably just go with the standard advice we give to our clients is to really be focusing on the U values and SHGCs for when they're out there shopping in the market. And I'm not sure whether maybe this particular question is coming from a DIY perspective as opposed to a NatHERS thermal comfort model perspective, because in the DIY tool, obviously you've got quite specific preset values that, I agree, can be a little bit challenging, but I think the best thing to do is to make sure that you're shopping around, you're talking to suppliers and finding what is the best solution for you. And if you're not happy with the glass spec that you have been given, going back to your consultant and getting them to, if it's an NatHERS assessment, rerun some calculations, talk to them about the problems you're facing with the color of the glass, with how dark it is, because we all know, just dropping those SHGCs isn't necessarily favorable for every aspect. It has daylight implications or reflectivity problems. So I would definitely work with your consultant to find a solution that you're happy with. Another thing that I would note is that in a lot of the testing that we have been doing here, we're noticing that the SHGCs staying a little bit more kind of in that 0.4 range is more favorable for both the heating and cooling and total load compliance, whereas previously in the current NatHERS standards, your heating and cooling loads can play against each other quite a lot. And if you're really chasing a cooling load, dropping those SHGCs is quite favorable. Whereas now you have to have a balance, and that total load is forcing you to have a balance between heating and cooling. I hope that answers.
Thanks, Hayley. No, that sounds great. I While we're on glass, there is another one that's risen to the top with a number of thumbs up. In terms of concern, do we have a concern that tying glass area to floor area is penalising smaller homes, acknowledging small home footprints are environmentally better but harder to pass? Not sure if that's...
Yeah, look, I think the idea of smaller footprint homes has been a challenge for all of us as an assessment point of view, because of the fact that you do have a smaller footprint and you're using a software system that's designed to model houses that are slightly bigger. So sometimes the results can be a little bit off-putting, but I'm hoping that maybe the new DIY format, when it comes out, might address that issue and hopefully provide a better assessment process for those smaller footprint designs. But there's no doubt that the higher glass to floor ratio, whether it be in smaller footprints or larger footprints, it's the same for both. I mean, you certainly need to revisit it. If you want to stick with more glazing, then you've certainly got the option of doing so, but it's just going to mean that you're going to need higher performance staff class to compensate.
Great. Thanks, Ian.
If I can just add just on the end of that as well, again, working with your assessor if you have got a preference, but, you know, I guess it's kind of spoken in the industry that a favourable glass to floor area is like a 20 to 25% for like ideal thermal comfort. But, you know, more architectural designs and particularly some of these really nice granny flats that we're seeing come through now are pushing up towards that 30%. And you can get it to pass if you work with the consultant shading screens, you know, insulation, building fabric as well. It's those projects, I guess, that are even further above that where you've got to pay the money for the window systems if you want to have those higher glass to floor area ratios. But always the lower the number, the better the performance.
Thanks, Hayley. Might be a policy question, just a clarification one, Daniela. Does the term submitted mean submitted to the portal, only New South Wales Planning Portal, or does it need to be accepted and acknowledged by Council to be ahead of the 7-star requirement?
In short, just to be submitted. And this is something that has come up since August last year, and it is something that we're going to clarify in an upcoming circular, so watch this space. But in effect, if you've got a valid certificate and you lodge your development application and the basic certificate online through the planning portal, it's submitted and you know, it doesn't have to be accepted by Council yet for your basic certificate to continue to be valid. So, yeah, we're going to clarify that, but yes, it just needs to be submitted within the first 3 months of validity.
Great. Thanks, Daniela. Maybe one for Martin. I think you answered this in your presentation, but both for small single-storey houses with smaller windows need a cost for 2-storey larger houses?
We didn't test that during this testing, but we are currently testing that. Because, like I said, we're starting to look at new designs. A lot of those new designs are 2-storey because we're, like you said, smaller blocks. We're going a little bit higher now with the 2 stories, but we haven't actually got costings in that per se at the moment. But yeah, they are to come. But yeah, we're still. I think it is going to be in the area of like that 10 to 15,000. You know, that we're seeing in the single story. So it might be a little bit bigger. Again, I'm not too sure until the costings come out. So
yeah, great. And the team behind the scenes have also mentioned they'll be publishing, the department will be publishing more case studies and examples of designs that meet the higher standards as well. There's a scenario here as well, asking about south-facing dwellings overshadowed on each side. So can these still be built?
Yes. So that testing we did there, we actually did test it with overshadowing 2-story buildings. Our energy assessor did assess that at the worst case scenario. So he's aware of that. And yeah, again, talk to your energy assessor. He will walk you through that. And there is things that you can change and manipulate within the BASIX tool, like Hayley had said, you know, to meet those ratings. So yeah, it can pass. You just need to be able to manipulate it. Yeah.
Yep. Great. Thank you. One about regional area impacts. question, have regional area impacts been assessed in arriving at the thermal comfort targets? Maybe that's one for you, Daniela.
Yes, and in short, yes. So when we undertook the cost-benefit analysis, we looked at all the different climate zones across New South Wales, and I did mention very briefly up front that the higher standards won't apply initially in the North Coast climate zones and for certain types of residential development from 1st of October because the figures didn't stack up. So we modelled a small, medium and a large dwelling across New South Wales and low-rise, high-rise apartment buildings. And we only proceeded with the higher standards, including the thermal comfort standards, where the figures stacked up, where the benefits outweighed the costs.
Great, thank you. Another one about another scenario, and perhaps this has been touched on, but wood orientating living spaces towards the west, is it a disadvantage when it comes to basics? If so, how could we offset the setbacks? So does that make sense?
I think probably if you've got a west-facing elevation, then the critical thing is shading, basically.
Yep.
That's obviously where you're going to be getting most of the hot summer sun entering the home. The first thing you need to consider is how you're going to shade that summer sun from hitting the house. So shading would be the key.
Yep. And does that go into, it's another one on glass as well. If you reduce the amount of glass on the north face of a building, won't that work against getting winter sun into the home?
To a certain extent, it can. So again, it'll come back to shading. It'll also come back to the type of performance you use on the glass. If you've got north-facing windows and you've got limited glazing, then you can offset that slightly by having better performing glass that's got a higher solar gain coefficiency value, which will actually allow more sun rays to come in through that glass. So it can be slightly offset by doing that.
Great. Thanks, Ian.
Can I make a comment?
Yep, Hayley.
Okay. I think it's also important to remember that there's lots of different types of buildings as well. So if you're a project home builder, getting your assessor in early to run batch files, your key designs on multiple orientations gives you such great data on how it performs across an estate. But, if you're an architect designing an architectural home that has a view, say, to the south, then that's your focus and the client wants to have the glass there. So getting, again, the assessor involved early to help and support you through the design process to ensure that what you do deliver to the client is capable of achieving the targets is really critical. And then you can work with them on what are the key factors that they want to have in the design and, what is a key feature room where you do want to maximize the glass area versus where can we pull back on the glass. So being interactive in that process, particularly for architectural homes, is going to be really, really critical.
Great. Thanks, Hayley. This is one for Martin. Just in terms of your examples, Martin, what type of heating and cooling was assumed as a standard inclusion?
Oh, we just did a normal ducted AC. That's across all our products. Again, so we're more of a spec builder. So we had originally modeled that from the beginning, and we were getting them passing. But conversely to that, you're looking at the higher thermal properties requirements. So there's a give and take scenario in there. So I thought people to be aware of that as well. So but we use a normal ducted AC unit.
Great. Thank you.
I'll make a comment on that too, if that's all right. Yeah, it's seemingly happening for us where we've moved to 7-star and the actual total heating and cooling load is radically lower than, say, 5-star by about 50%. I think it's 30% lower than 6-star. It would seem that it's probably the case that air conditioning mechanics aren't keeping up with this, so that the actual sizing of the actual air conditioning units to match the home or the apartment, they're probably still too large and too much capacity. Now, it seems to be, as a rule of thumb, that the smaller air conditioning units generally run at a higher efficiency rate a lot of the time as well. So there's an opportunity here where I think, as well as saying to people, hey, you're going to generally save money from running costs, but you're going to have to manage this higher capital cost up front through more mortgage finance, whatever. there are some potential savings on the sizing of equipment that actually goes with the home as well, because they're just more efficient too. So it would be nice to see that actually occur too. It's a fundamental change. We're dancing around glass a little bit here too as well. It would be a sensational thing for New South Wales to see our actual window manufacturers change their manufacturing processes to be predominantly double glazed from single glaze. And I sort of hope that this change breaks the back of that, and we do see that step change to basically manufacturing lines for double glazed, hopefully thermally broken as well at the same time. And that way we'll all have new model homes with double glazed glass and all the benefits that can bring if it's done properly.
Thanks, Troy. Might have to help me with this. All roof water directed to a 2,000 litre tank, question mark?
So that was with our modelling, yeah. So that's all our water directed. So we've got a, was it known as, I forgot what it's called.
Oh, you mean
Like full sealed system. Our rainwater is just all directed to the 2,000 litre tank.
Charged.
Yeah, charged. That's it. It will change depending on the size of your land and your roof space as well. So we have seen in some of our other testing that tank size changes depending on the size of the roof and land as well. So, but yeah, we charge all our roof to that water tank and overflow it to the street or an easement. So.
Cool, thank you. Again, there's a few acronyms here. STCs should be even, but a heat 29 STC pump scores differently to a 29 STC solar. Why? Is that something that... No?
I think the STCs is a tool in itself to calculate how the STCs are calculated. I'm not so sure all of us have got the technical expertise to go in and dwell into that. So it's probably more of a question for a supplier than it is.
I think it probably also then would have something to do with like the fuel type. So like if you just have a heat pump system versus if you've got, a solar gas boosted. So that also comes into the equation with basics. It's not just the performance of the individual system itself.
I think that's as good an answer as we're going to get. Thanks, Hayley. So some more technical stuff. Will increasing the size of the photovoltaic system help with the performance of the building? Not sure who to direct that to.
Well, from a BASIX point of view, the way BASIX assesses the building is that your solar system is a component within the energy section of BASIX. So to answer the question, will it help thermal performance? The answer is no. So it will certainly help you achieve an energy target, but it doesn't help you with the thermal comfort target.
Great. Thanks, Ian. I'm not sure if you would answer this one, but do the new basic standards signal the death of the Queenslander?
Given BASIX is not in Queensland, I doubt it.
There we go. The answer for that one. Would UPC frames be the first step before thermal break frames?
I think it touches a little bit on what Hayley was saying. I think the critical numbers to look at are the glazing values rather than the type of frame. So, UPVC frames do perform well, but there are thermally broken aluminium frames as well that can perform just as well. So, I think it's a matter of looking at the supplier, the type of window, the profile of the frame. All of those aspects will come into decisions on the type of window system, type of window frame you want to use. But I guess the bottom line is going to be is the performance of the window system itself. So the frame and the glass, look at those glazing performance values, and then identify what type of frame you want to go to, because those are the factors that will determine the energy performance.
Great. Thanks, Ian. Is there anything further from, was it Hayley?
I just was to say availability, like we will see a change in what the market is required to deliver around windows. I mean, particularly architectural homes, I think they kind of get forgotten a little bit in some of these conversations, but the frame is going to be so important to achieving the rating that you're going to have to shop around and understanding the suppliers and can they meet the demand. I guess it's something we're going to have to see as we go along. But obviously the WRS website is just a great resource to quickly chuck the values in and see who's offering what on the market.
I think if I could just add to that, probably one of the key benefits that UPVC frames will add moving forward is, given we're going to be moving to high performance windows, and if people are looking at large window systems in size, aluminium is obviously a heavier material, so the weight of getting that product to get windows in situ, and a PVC frame can tend to be a little bit lighter. So maybe logistics on building sites that needs to be considered as well.
Yeah, that's a great point. And I guess another element with windows is it's not always the rating that is contributing to the cost. It's the size. It's like Ian said, the tracks, the runners, how much weight can they handle? There's a lot of factors that go into the cost of the system, and working out, is it the U value and SHGC supplied in the certificate, or is it maybe some other factors in the design that are contributing to that cost increase?
Thanks both. About thermal mass. So why add thermal mass to the external face of insulated external walls? Is that for you, Ian?
Yeah, thermal mass is something that is worthwhile in cooler climates. Obviously, the idea of thermal mass is that it basically stores the heat and then releases that over night time is the general rule of thumb for thermal mass in a building. And again, it comes back to the orientation as to how the house is orientated and where that thermal mass is located and where that's actually achieving the sun. Not by just having a thermal mass in an area where it's getting westerly sun and then in a position where it's in a hot climate, it can actually be more detrimental to a design rather than being better performing. So I think thermal mass has got to be used sensibly. In general terms, we'd say thermal mass is a benefit. But you need to consider where it's placed and the type of thermal mass and the climate it's in.
Great.
We have found in the modelling we've done for some apartments, actually, that, just reiterating what Ian said, used carefully, thermal mass in the living areas of internal walls in some apartments can actually produce quite a large benefit. Yep. Carefully applied. Now, that's sort of contra to a lot of construction methods used for apartments to put thermal mass in internal walls, usually quite lightweight. But I don't know, I think it's one thing to watch this space. If someone can provide some easy to construct solution for thermal mass in apartments, that'd be pretty beneficial.
Yep.
Thanks both. Back to Troy and Hayley. Class 2, all electric appliances. What's that doing to base building loads? Is that going to mean substations on all projects, and is that being factored in?
Question.
So it's it's interesting. Do we come across this issue a lot these days? And it's the one, you'll get a Canberra service engineer to come and help answer the question, because there's a lot of electric places in Canberra already, which is interesting. Yeah, it may not be where you come from. There was an initial fear that electric vehicles would blow the demand out of the roof, but the reality is that electric vehicles are quite easily either bumped down the list from a load management perspective or put to a nighttime out of peak, so they're not a problem. Where we've run into problems with all electric buildings, it is switching to induction tops that will quite often contribute to, your 6, 7, 8 p.m. load. If you're in a mixed use building where you also want to convert, say, cafes downstairs in a big building as well to electric cooking as well, they will also do some pretty big increases to demand as well. So look, I think it's a reality that if you're pulling out the gas services from a building, there is going to be, on average, larger substations. I think that's just a reality that, even with the increased energy efficiency from some electrical appliances like heat pump hot water compared to gas hot water, you are still going to need a higher electrical load at the end of the day. Something we've brought up with DPE actually as well, to actually get people ready for the fact that substation outcomes are probably going to be larger on average through time. So you're putting a larger substation in at some cost. you're pulling gas services out at reduced costs. So there are some trade-offs there to remember at the same time.
Great. Thanks, Troy.
Can I just add, I guess, a few points in regards to Class 2? So I guess Basics at the moment has the ability to include quite a lot of appliances, which won't actually be in the new tool. So they were specified and obviously in the report then required to supply. Not saying that you're not going to have appliances in the building, but what the Basic certificate is controlling and requiring in the energy section will be quite different. And what we're finding is actually a little bit less onerous than what it is currently. And it's important, I think, to also consider the fact that a lot of developers are already doing electric buildings. You know, even just the simple Green Star standard really favours that pathway. And a lot of these bigger developments, you know, they go for Green Star anyway, so they're already electric buildings. So it is already being done, and it is working.
Thanks, Troy and Hayley. A few questions on stud walls. Clad frame designs in southern New South Wales are predominantly requiring R2/2.5 wall batts. How are any increases going to actually fit within a 90 mil framed wall?
Yeah, well, you're right. I mean, a 90 mil frame wall will only take a certain level of insulation, and it comes back a little bit to what Troy was saying with suppliers. I think, like windows, we're gonna have to start over time coming up with better ways of condensing products to fit within 90 mil cavities and trying to increase the R values of those products. But right at the moment, what's on the market at the moment predominantly is a typical glass fibered batt. That in order to fit within a 90 mil cavity, it'll only give you a maximum R value of 2.5 or 2.7 if you go to a compressed batt. So I think where this will drop, the whole 7-star process, we'll see that we'll start to see more manufacturers coming out with more innovative products, and we'll start to find ways of building better wall systems and higher R values. We already see the use of products like EPS walling, the expanded polystyrene type walling, which is adding even more added value in lightweight construction. So I think, again, it's another thing, watch this space. I think we'll start to see more products offering better insulation, which again is then going to offset some of the other added costs that we're coming up with at the minute. So, and it's a little bit like the glass, what Troy was saying with the glass is that I think the more we start using the glass, more builders and specifiers start specifying higher levels of glass, that's going to be putting more pressures on the window suppliers to actually start manufacturing these locally, because the cost of transport is going to start getting extreme, and that's just going to be a win-win situation for everybody.
Thanks, Ian. Maybe one for Daniela. Someone's hoping to get clarification on requirements in specific areas: Orange, Bathurst, Oberon, sorry.
Look, I don't know on the top of my head the climate zone that they're in, but we do have climate zone maps on our website. The others might be able to.
I can just make a quick comment on it if you like. So I guess from our experience, I guess the further out west you're going, the easier it is to comply with the heating and cooling loads. I think just the balance of them. We're finding the most challenging area to particularly meet 7 stars is climate zone 56. But yeah, I think in those areas as well where the temperatures are a little bit more extreme, whereas in climate zone 56 here in Sydney, you kind of have a bit of a balance between those heating and cooling, which is more challenging to get a pass in NATHERS, in my experience. Not sure if you've got anything to add on that, Ian.
Oberon,
Oberon.
So
cooler.
What Hayley's saying is that your cooler climates, and because the way the BASIX targets operate is all based on climate. So obviously in those cooler climates, the focus is achieving more heating load requirements. The cooling load requirements are less of a requirement. So it does make it easier to try and get to those requirements, because you're tending to focus on just the one type of heating load requirement, whereas the cooling type climate tends to fall into place, whereas when you get into the climate zone 56 that Hayley was talking about, where we're more moderate and we're actually trying to achieve 2, it's sort of like trying to fit the scale. You're getting, as you try and improve heating, you then lose your cooling, and it becomes a juggling effect. So I agree with Hayley. 56, climate 56 is probably one of the more challenging climate zones.
Yeah, so west of the Blue Mountains is a bit easier because that balance is right. Whereas, yeah.
Fly screens. How do you install fly screens for NCC fall prevention in NatHERS software? What software provides this capability? AccuRate Sustainability doesn't. Is that one?
Yeah, well, fly screens aren't considered an item to be included in thermal performance. So currently, at the moment, fly screens don't come into consideration, so they're not modelled. Certainly not modelled as a fall protection device, but they're definitely not modelled in relation to any thermal performance.
So they're not modelled, but the one thing that I'd probably just note is that it impacts, I guess, from a only secure fall prevention screens, the openability of windows and the ventilation that you get. So, for example, a second story awning window, you're going to have a fall prevention on that window. And it's preventing you from getting, say, a 90% ventilation through that window. You're modelling as 10%. But NatHERS has default settings, from what I understand, in regards to, things like fly screens sealing the building.
Great, okay. Thank you. I think I asked that. Sorry, there's a lot of questions. Keep them coming. I've only got a few minutes left. And I may not have mentioned that we'll try to answer the ones that we've missed today. We'll update the FAQs that we have online to accommodate some of these possibly more technical questions. Here's one about brick veneer construction. Would a reverse brick veneer construction significantly increase basics points per the new BCA 2022 requirements?
I guess you can put that in the same comment that we made about thermal mass. I think it's one of those things that's dependent on the design, dependent on the climate, and dependent on the orientation of the building. But again, like thermal mass, generally speaking, reverse brick veneer adds benefit, but you do have to consider it where it's placed in the design.
Right. Thanks, Ian.
And I think another thing to add on it is the buildability and the likelihood of the brickies wanting to do it. Sometimes, I guess, with things that aren't quite as conventional, it can be a little bit harder to see them actually fulfilled on site.
Yeah.
Thanks, Hayley. Maybe last one. Where are we sitting in the context of other countries on basics performance? Are we making a big deal given other countries are using triple glazing, for example, as standards? So what's stopping us?
I think let's crawl before we run. I mean, we're going in the right direction, and we will get there, but we're starting from a much lower base. And I think that it's fair to say that I think we don't want to jump too quickly and blow costs right out of the water. Let's work our way there. Let's educate the public. Let's educate the builders. Let's educate the suppliers. Let's start building up some momentum, and then we can move forward from there.
That's right. I completely agree, Ian. And I mean, this journey for basics started in 2019 when the energy ministers across Australia got together and agreed to a trajectory for low energy buildings, and the introduction of the CEP end of last year reaffirmed, I guess, New South Wales's commitment to, make those steady steps to deliver net zero buildings. And so it goes as far as committing New South Wales Department of Planning to review the standards every 3 years. So we'll be doing that. Where we sit in the international scene, I genuinely don't know, but I think we're in a pretty decent position in New South Wales compared to other jurisdictions across Australia, because we've had a whole of house approach since BASICS was introduced in 2004. And so the other jurisdictions are only starting that now. So it's going to be a little bit trickier and a bigger adjustment for them. So I think we're in a better position, and, you know, we'll just keep chugging along.
Yeah. Danielle, I would add to that. I agree. The whole of housing is really important, and it's a bit of an old chestnut, that one. Australia is not as good as Europe. Now, we're totally different climate to the cold sections of Europe, obviously. So when we're hitting 7-star thermal performance, the total carbon intensity of the house from heating and cooling is dropping down to 15% or less, something like that. So the whole of house picks up the other 85% of carbon intensity of living in a home. So it's why I'm actually quite excited that you guys have gone further than you probably needed to in some ways to even out the actual energy equation, so that all electric is now coming in as a much leveler playing field to actually work through BASICS now. So like we work from BASICS here over to Green Star over here, and more aspirational than that again. And I think BASICS has been focused on low carbon emissions per person, and rightly so. And I think it's in a good spot for, as a baseline sort of underpinning, to actually get us to a spot on low carbon emissions from which we can exceed again. I think it's not too bad. I think it's got great elements to it.
Thanks, all. It's a good way to finish today, I think. So that's it for today's session. I'd really like to thank the panel for coming in today and answering tough questions. I understood some of them. So look, on behalf of the team, thanks again for your interest and engagement to date on the higher BASICS standards and helping to build more sustainable homes. As mentioned, we will make the recording of the session available on our website. As I said, there are a few questions we didn't get to today, and we'll update our FAQs to accommodate those. Just before we sign off, I want to mention that in the coming months, we're looking to run another webinar on all building types covered under the Sustainable Building SEP. An invite will be sent out to everyone here today. So in the meantime, thank you very much again for joining us, and have a great evening.